What we have here is more practice with sine, cosine, and tangent. Again, trig ratios means we are dealing with right triangles. As long as we have a right triangle, we can use these different ratios to figure out lengths of sides and or angle measurements. So how do we remember what sine, cosine, and tangent are equal to? Well, we have the acronym SO, CA, TOA, where our sine of our angle is equal to the opposite side over the hypotenuse. Cosine is equal to the adjacent over the hypotenuse. And tangent is equal to the opposite side over the adjacent side. And we can use these to figure out the different ratios. For instance, in number 1, we have to figure out the measure of angle x. Well, we have the measure angle x, and we have to figure out what sine, cosine, and tangent is. So for angle x, we need sine, which is opposite over hypotenuse. So opposite would be 1. Hypotenuse is always across from our right angle, so it's root 10. So 1 over root 10. Cosine is the adjacent side, in this case 3, over the hypotenuse, which we just said was root 10. Tangent is opposite over adjacent, 1 over 3. If I wanted to deal with angle y here, sine would be opposite over the hypotenuse. So the opposite in this case is 3, and the hypotenuse is root 10. Adjacent, for cosine, adjacent would be 1. Hypotenuse is root 10. And then tangent being opposite over adjacent, 3 over 1. So if you take a notice, when dealing with one angle, the sine is going to be equal to the cosine of the other. So sine of x is equal to cosine of y. Also, cosine of one angle is going to be equal to the sine of the other. So cosine of x equals sine of y. And then the tangents are inverses. So 1 over 3, we flip it to be 3 over 1. And we can actually use that to our advantage in order to fill in a chart like this. For instance, P, we are given sine, cosine, and tangent, and we have to fill in the line for Q. Well, we know that cosine of P is going to be the sine of Q. So it's going to be 6 over square root of 157. We also know sine is going to be sine of P is going to be cosine of Q. So 11 over square root of 157. And we know tangents are inverses. So all I have to do is take the tangent of P and flip it to get the tangent of Q. So 6 over 11 would be our tangent. But what if we only have 2 out of the 3? For instance, in number 3, we are given angles alpha and beta, and we're only told sides 4 and 6. So 6 we know is the hypotenuse because it's across from the right angle. And 4 is one of the shorter sides, same with the unknown side on the other. Well, anytime we're dealing with a right triangle, we can always use the Pythagorean theorem. So Pythagorean theorem states the square of a short side plus the square of the other short side is equal to the square of the hypotenuse. So 4 is a short side, so we square that. We don't know what our b is, but we do know our hypotenuse is 6. So 4 squared gives me 16 plus b squared, and 6 squared gives me 36. We subtract 16 from both sides, and we get 20 is b squared. So to get just b, we take the square root of both sides, and the square root and square will cancel each other out, leaving me with square root of 20 as our short side. So we can use these measurements to fill in sine, cosine, and tangent. So sine of alpha, opposite over hypotenuse, root 20 over 6. Cosine of alpha, adjacent, 4 over hypotenuse, 6. Tangent would be opposite over adjacent, root 20 over 4. And then we can use the relationship we just saw to fill in for angle beta. So sine of beta is going to be the same as cosine alpha, 4 over 6. And again, opposite over hypotenuse, 4 over 6. Cosine of beta would be adjacent over hypotenuse, or sine of alpha, so root 20 over 6. And then tangent would be the inverse from alpha, or we could always check it. Opposite over adjacent, 4 over root 20. Then we can use this to fill in any table that we're given. And we're not going to worry about the fourth one here. However, number 5 is a pretty lengthy word problem. If we can do number 5, we can pretty much do any basic trig word problem. So we got a fisherman here at point F. He has favorite locations at points A, B, and C down there. And he's 14 miles from line AC. So we got to figure out how far he's going to sail in miles. So he's going from F to A to C, and then back to F. So what we need to do is pretty much label what we know. We have our angle measurements here, and we're told that we are 14 miles from the line. So if it's a straight shot, we got 14 miles here. Now, what can we do here in order to figure things out? Well, fortunately, we have this nice little right angle down here at point P, meaning we have right triangle over here, right triangle there, and then the bigger triangle FPC is also a right triangle. So we can use our trig ratios to figure out our unknown sides. So we need to figure out F to A. We need to figure out somehow A to C, and we also need to go from C back to F. So we got those 3 sides that we got to figure out. Now, fortunately, we have one side of this right triangle in which we can find out the other 2 sides. We have an angle, we have a side, meaning we can figure this out. Now, to figure out the hypotenuse here, we have an adjacent side and we have a hypotenuse. So that means we're going to be dealing with cosine of our angle here. So here we have triangle FPA, and so that means we're dealing with an angle measurement of 35. And cosine is adjacent over hypotenuse. So we have 14 over our hypotenuse, FA. Now to figure it out, we have to get h by itself. So what I want to do first is get rid of this fraction. So we'll multiply by what's in the denominator, which will cancel it out. So we have h cosine 35 gives me 14. And we'll divide by cosine 35, which will cancel out on the one side, leaving me with h equals, and again, we just divide 14 by cosine of 35. And we get 17.1. So this means from F to A, we've gone 17.1 miles. And now we can figure out what A to P is. We're still dealing with the smaller right triangle that's facing off to the left here. So we need the side opposite, and now we have a choice of 2. So we have side 14 versus 17.1. 14 is a little nicer number, so I'll deal with 14. So I have opposite and adjacent, so tangent. So we're dealing with tangent of 35. Opposite is our unknown x over the adjacent side of 14. So I'll multiply both sides by 14 to get rid of the fraction. So they'll cancel out. So we're left with x. So 14 times tangent 35 means 9.8. So from A to P is 9.8. So far so good. However, we still have the rest of it. We have to go from P to C and back from C to F. Now, ordinarily the smaller triangle in the middle here, yes, we're given a measurement, but all it would really do is give us P to B and it wouldn't help us out in any way, shape, or form. However, P to C is still part of the big triangle FPC. So first thing, I'm going to combine these 2 angles to figure out how much it really is. So this part's 16.5, the other part is 26. So together, when I add them, means I'm dealing with an angle measurement of 42.5 degrees. Now, just like before, we have an opposite side and adjacent side of 14. So we now have tangent of 42.5 is equal to our unknown x over 14. And just like before, we'll multiply both sides by 14 to get rid of the fraction on the one side, and we end up getting x all by itself. So all we have to do is multiply 14 times the tangent of 42.5. And we get 12.828. We'll round up to, we'll keep it single decimals, 12.8. So from P to C is 12.8. And last but not least, we have to figure out what F to C is. So now we have an adjacent side and a hypotenuse. So again, I'm picking 14 because it's a nicer number than 12.8. So adjacent side of 14, unknown hypotenuse, meaning we have cosine. So we have cosine of 42.5 is equal to our adjacent side, 14 over our hypotenuse, our unknown, x. So we'll multiply both sides by x, which will cancel it out. So we have x times cosine of 42.5 is equal to 14. To get x by its lonesome, we'll divide by cosine 42.5. It will cancel out on the side with x, leaving us with just x, and then we'll divide 14 by cosine of 42.5. And we get 18.988, so we'll round up to 19. So from F to C is 19 miles. So here we have F to A is 17.1, A to P is 9.8, P to C 12.8, and then back around would be 19. So last thing we have to do is add those up, and we'll have how far he has gone. So 17.1 plus 9.8 plus 12.8 plus 19. For a round trip total of 58.7 miles. So again, this is taking a larger picture, breaking it down into pieces, and we can use these trig ratios to figure out missing lengths of sides.